I hope everybody has joined us by now. I'll be starting the webinar. As I did mention that the webinar will be focusing on the design and construction using Revit, structural modeling, and BIM360. This webinar will be covering the following. We'll be looking at the background of the project, looking a bit at the scoping mission, which involves aspects such as geotechnical investigation, the survey, hydrology study, the site selection. We'll also look at geometry, structural solutions, BIM360 implementation, and then we will end this off with a Q&A. Please feel free to type your questions in the question and answer box during my presentation. And at the end of this presentation, you will have a chance to ask these questions and I will be answering. I am also not alone. I will be with Mr. Johnny Stradom, who's the technical director for structures this side, and he will be assisting with some of the questions. A bit of background to this project. So WSP was appointed as consultant engineers by UNOPS for the scoping mission and detailed design documentation for the construction of the Nyara River Bridge. The Nyara River is basically situated in the Arua district in Uganda. This bridge will be linking the Ofua zone and the Omuga zone, and these are both part of the Rhino Camp settlement and as well as the Rhino Camp settlement extension. The population of the Rhino Camp settlement is at an approximated 120,000 people, and these are mostly South Sudanese people. The bridge will provide vehicular, pedestrian, as well as livestock access across the Nyara River. The reason this bridge is needed is because it is not possible to cross the river during high floods and high currents. In fact, there have been reported incidents of death caused by overflooding of the river. Most importantly, the river is also needed because the alternative route to travel between the two zones is 54 kilometers at an approximated time of 80 minutes. As you can see with this map that is provided here, as my cursor is moving, you will notice that this direction here is the direction of the river. The bridge is located over here, and over here on the northern side, we can see the Omuga zone. On the southern side, we can see the Ofua zone. As mentioned before, that the benefits of the bridge, most importantly, we're focusing on safety. It's going to be a safety improvement as it's going to be providing a safe passage across the bridge. The bridge will also reduce the travel time and distance, which was mentioned before, a travel distance of 54 kilometers at an approximated trip time of 80 minutes. It will also increase logistical time and efficiency. There will be saving of road user costs such as fuel and wear and tear and everything that has to do with vehicles. The bridge will also increase the cost efficiency delivery of basic services and needs such as water, food, nutrition, as well as healthcare between the two settlements. In the construction of the bridge, there will also be an establishment of sources of local integration. And not only with that, but with the two markets that are existing at the settlement and camp settlements, there will be also an increase in the local community, the economy of the local community. The scoping mission basically comprised of the following. There was a site visit by the design team, and the design team included geotechnical people. It included some engineers from this side as well, amongst others, and surveys. There was a topographic survey, we had an environmental impact assessment, we had a geotechnical investigation, a traffic study, as well as a hydrology study. This slide here is going to summarize basically what was done during the geotechnical investigations. There was drilling of 2 boreholes, which were varied from a depth of 6 to 10 meters at different locations. The rotary drilling method was utilized to drill through the soils and the rocks that were present there. SPTs were conducted at every 2-meter depths in the boreholes. 5 trial test pits were also manually excavated at a depth of 3 meters. The material that was then recovered from the site was taken to laboratories for further analysis. This is just a map of the geology where the boreholes were taken, and pretty much the boreholes were basically taken on the banks of the rivers, as you can see as noted over here. In conclusion, it was noted that on the site it was mostly made up of clay sand soils. The bedrock was also shallow enough since we saw some rock outcrops that were appearing on the river. The ground conditions of the chosen site, and I'll be taking you through the process of choosing the site. The ground conditions of the proposed site were actually favorable for pad footings on 500 kPa bearing pressure capacity. As I did mention previously that there were two site choices that were there. We have site 2 over here, and then we have site 1, and site 1 presents itself in two locations as noted over here. This is a bit of a repeat of the previous slide, but however demonstrates the sites now on Google Earth images, and you can see site 2 is over here, site 1 and 2 are basically over here. At the end, the decision was made to choose site 2, mostly because this site only requires one crossing. It also has favorable geotechnical conditions, and the hydrology of this site is also better suited. I will explain what we mean by the fact that we only required one crossing at site 2 in the next couple of slides that will follow soon. These are the images of site 1 as it currently stood when the scoping mission was conducted. Images of site 2 during the conducting of the scoping mission. The geometric team that was involved decided that the road should be of a width of 11.8 meters, taking into consideration safety, as well as 2 3-meter lanes. But then most importantly, there needed to be provision for pedestrians as well as other livestock that could be crossing the road. And these were provided by a 0.5 meter shoulder rounding, but then allowance was made with a 1.5 meter sidewalk. Over here, we can see the horizontal plan layout of the bridge. And this drawing here was basically presented as one of the general arrangement drawings that went along with the bridge. You can see the position of the bridge over here, and these are the access roads that needed to be constructed in order to make it a safe approach to the bridge. The hydrology found that the catchment area was 209 square kilometers. This is quite a massive area for a bridge, and this is why this river was actually quite dangerous. If an individual finds themselves at the lowest position, at the lowest point of the river over here, should flooding take place, or a flash flood of sorts take place up here along the northern side of the river, the individual here would have no clue of what is happening until they see the flood coming, which is why it has caused so many deaths in the future. The river's hydraulic length is 32.6 kilometers, with a height difference of 380 meters and a basin slope of 1.16%. What you see here is a image that was taken from a modeling software, hydrology modeling software called HackRes. What we see here are different flood lines, the 1 in 50 and the 1 in 100 flood line. This is without the bridge in place. The bridge flow is in this direction, the northerly direction in our instance. The second hydrology image is one that shows the bridge in place as noted by these leaders over here. An interesting thing to note about site 1 and site 2. If we can remember and go back a few slides where we showed site 2 as being here and site 1 having 2 crossings, it's because that during high rainy seasons, as the river flows up this way, it gets to the bridge. Some of the water does eventually make it through, a bit of flooding here on the sides. But however, we notice this backflow or a back current that starts developing once the river is in place. And not only when the river is in place, but even without the river, this back current also still does exist. With that being said, the chosen hydrology method or method of studying the hydrology in this instance was the SCS method. The SCS method produced the peak flows as we can see over here, 1,100 for a 100-year flood, and 890 cubic meters for the 50-year flood there. From the calculations, recommendations were then derived as follows. The bridge is to have a rise of 6 meters, i.e. a clearance of 6 meters. This clearance of 6 meters was not really necessarily a choice made by the hydrology, but rather this was because of the geometry of the site itself, as it was noted that it had quite steep embankments, and for the road's minimum slopes connecting to the bridge to be met, we needed the rise of the bridge to be 6 meters. The span is also to be 24 meters. 2 spans of 24 meters rather. From the hydrology, we then derived the structural solutions. We kept the spans the same at that 2 24-meter spans. One span of 48 meters would be way too expensive because of the deep members and also different bridge considerations and different bridge solutions. 24-meter spans can be constructed with relative ease, and the bridge soffit and vertical alignment were determined by the geometric requirements, as we did mention previously. So now comes in the structural solutions. We had 3 structural solutions that we considered. The first solution is a simply supported precast beam and slab. As you can see, the advantages of this solution is that ease of construction. There's ease of construction over the river without there necessarily being a need for formwork or anything, as well as the concrete elements are going to be relatively free of maintenance except at expansion joints, etc. The disadvantages of this is that the availability and transportation of the precast beams is going to be a bit of a challenge, considering that this is in Arua, some kilometers very far away from Uganda and even the capital. Also, this construction method would require that the contractor has very skilled laborers who are able to do post-tensioning. The second option that was looked at was a steel truss with a cast in situ deck. The advantages of this option is that it's quite aesthetic and quite easy on the eye. It also has superior strength because it's mostly steel elements and members that are used, and it has minimal environmental impact. But the disadvantages rather of this option is the fact that at the end of the day, we're still looking at the location. This is in Arua, deep in Arua, in the rural villages of Arua, without much resources available to use. So the problem now comes in the fact that it's going to be difficult to manufacture and assemble the steel trusses on site. And also the steel elements will require a lot of maintenance. The third option that was investigated was a steel girder and cast in situ deck. This option now is quite advantageous because now it's a combination. It brings in both a combination of concrete and steel, and thus giving us very great strength. It's also a labor-intensive method, thus creating local employment opportunities even for the locals. The steel girders can be easily transported and assembled on site. The disadvantages is that the steel girders still need to get to that site, considering the distance from the capital areas and areas of trading. The steel girders will also need future maintenance. Now, those options were all now taken together and collected like this in the table, as you can see. The options were compared. We looked at cost, constructability, traffic accommodation, health issues, health and safety issues, future maintenance, potential for future widening, as well as life cycle costs. And in the end, we came with a decision that option C was the best recommended option because it was easy and efficient to construct, considering that it reduces the risk of formwork being washed away by the river current, and also the fact that it creates employment opportunities. Now, in bringing this project together along, it was brought together manually via this workflow, in that we started on Midas with the designing and modeling. From Midas, we then exported the section into Revit. From Revit, we then had to now move from Revit to Civil 3D by producing 2D drawings, because the deliverables were supposed to be in the form of 2D drawings. So the 3D model from Revit was then used to produce these drawings. However, in the future, we are considering a more different approach using Dynamo, in that we can take the road model that is coming from the geometrics team and the pavements team, and if there is a need then to make any changes on that model, those changes can be made in Microsoft Excel. From there, these can be exported into Dynamo, and then from Dynamo, we move over to then the modeling that could be happening in Revit. This is how we're looking at doing this project and similar projects in the future. Over here, you can see the Midas model. We can see the deck that was modeled, the girders, as well as the pier. And at the bottom there is an idea of how the moments were actually behaving to the given different loads. Now, because our client is based in Uganda, and bearing in mind that our client is also dependent on a lot of funding from external agencies as well as different ministries in Uganda, it was quite important. Although the technical nomenclature and the design is much more attractive to those who are more technically inclined, it is important that with people who do not have the knowledge of engineering and not necessarily technically inclined, it's important for them to have a visual understanding of the drawings itself. And thus we showed them these Revit models, as you can see over here. And over here we can see further Revit models that was presented to the client. And now this just basically makes it easier for the client to sell the idea to the funders as well as to the ministries. This is the final rendered model, as you can see. The issuing of documents was conducted through BIM360, as is noted by these screenshots from BIM. Document control, we also used BIM360. As you can see that there is revision control, as well as this function here also enabled us to say, look, if there is a problem in a drawing, it made it possible for us to be able to comment on the drawing, and for the client or even the potential contractors to be able to track live our comments, the comments that we are making on the drawings themselves. And if should there be any issues regarding correspondence of drawings or regarding revisions on the drawings, this was also easily picked up. It was further picked up by this method here that BIM360 has. For instance, you could see, for instance, the first revision is in red and the second revision is in blue. This thus made it easier for us to communicate our changes to the client and for the client to see where the changes on the structure were made. In conclusion, the project was successfully delivered digitally to the client. The project has gone out in tender and the contractors have responded with pricing. At the moment, we are waiting for the client to appoint a contractor, and all of this has been delayed by COVID-19. But ultimately, it just shows you the possibility that is within us to produce such projects at high quality, high standards, and perfect aesthetics. I'll show you a video rendering of this amazing bridge. This here is the Nyara River Bridge, the rendered version. The plan view of the bridge, as you can see, we've allowed for the 2 lanes over there and sidewalks as well. At this elevation view, you can even see the shape of the pier as well as how the abutments will look like. You can see we've also shown there the handrails for pedestrian safety that have been provided. And as we move over, if I can just pause the video just here so that you look at and notice that back current / backflow that I mentioned during the hydrology slides over there. That is the tiny river that actually required there for site 1 to have 2 river crossings. Without really having to waste too much time, I believe that this video has explained enough. And now the floor is open for questions. Thank you so much for taking your time and listening to this presentation. My name is Kulani Mapimele, ladies and gentlemen. Thanks.
Thank you, Kulani, for a great presentation. So before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform. And also you can download a PDF version of the presentation from the handout. We received some questions from registrants. Thank you very much for logging these questions. First question, what thermal consideration were taking as this bridge is in Africa?
Basically, the thermal loading of this bridge was done in accordance with BS 5400. So that was the consideration that was taken in.
Thank you. Next question, what are the best ways to reduce the force effects of thermal movements on straight bridge supports?
Well, it's to make sure that you allow for that thermal movement in between the members. And the way in which we did this in our design is that we used elastomeric bearings at the supports, which allow for restricted movement because of these forces.
Thank you. Next question, what software challenges were faced by using Revit to model the bridge?
Well, to start off with, Revit was not necessarily designed for the modeling of bridges. It's more a buildings type of software. So that alone in itself was a challenge. And because Revit works with things like levels instead of chainages, that in itself was a problem when we had to now import the surveys onto Revit, and therefore having to make sure that the coordinates within actually work out. It was also a problem regarding families because one family is not necessarily enough for modeling different types of bridges or the different bridge options that we had there. So trying to build a family that was adaptable to various scenarios was also a bit of a challenge on our side.
Thank you. Next question. Why were the 2D drawing not produced in Revit?
That was the client's requirements. In terms of the template that was given to us, the client wanted the 2D drawings to have been done in such a manner.
Okay, perfect. Next question. Is any information transferred from Civil 3D to Revit currently?
I'm not sure what that means. Is any information transferred from Civil 3D to Revit currently?
It's in the export, Kulai, in the export from from Revit to Civil 3D. It's exported and then edited in 2D.
Okay, I suppose that answers it.
Okay, thank you. Question about why not adding a second barrier to keep livestock from crossing into traffic?
Yeah, the thing is, when we did the traffic analysis, you will be quite surprised to find that we actually had much more people than cars that were crossing over that river. So the addition of a second barrier was not really necessary as the place itself does not have high traffic.
Thank you. We have another question. Can you further elaborate on how the migration of the model information from Midas to Revit was done?
Yes.
There's an import, there's an import from Midas. So at the moment, it's a manual import, but in future, it can be done with Dynamo.
Thank you. Was any rounding required for the pier in the river for the water flow?
Not necessarily. On the direction of the flow, the only rounding that would have been there was more aesthetics, but rather looking at the hydrology and the forces of the water on the pier itself and on the bridge itself, we noticed that rounding was not that necessary. But for aesthetics, yes, it was done.
Thank you. Another question. Is there any automation in Revit for any of the elements?
Could you just repeat your question?
Is there any automation in Revit for any of the elements?
Yes,
Not
we
at the
believe,
moment.
yes.
Not at the moment.
Okay. Let's wait for additional questions to come. Please feel free to add them in the question box. We have another question. Usually you model in drawing software and export it to analysis software, but it seems it has been done the other way around in this case. Is it true?
Yes, that is quite true. But to be quite honest, it depends on how you choose to model. A software such as Midas actually allows you to model without having to use the drawing software. The place, especially considering how simple the bridge was, and if you noticed in our Midas section, we only showed the girders, the deck, as well as the pier. So in this instance, it was not necessary to start our design model in a drawing software.
Thank you. There is a question if you can elaborate a bit more on the traffic study that was conducted.
Oh, yes. So the traffic study that was conducted, there were traffic counts that were done there. Unfortunately, it was left out of the slides. And what happened is that it was done over a period of 5 days, if I remember correctly. And what was noted is that the only peak in traffic actually happened on one of the days where they go to the market. There is a market in one of the settlements there, I believe it's Omuga zone, and that's when the peak in pedestrians was really noticed, as there were pedestrians moving from Ofua zone over to Omuga zone for the market. And also because the place is such a rural place, it's a refugee settlement for people who have escaped wars, especially from South Sudan. There isn't much traffic in terms of vehicular traffic. A lot of people, they are still walking, and a lot of people, they are just basically depending on livestock. So you will notice that, yes, indeed, that the bridge did provide for 2 traffic lanes, but that was because the standard in Uganda, because of the standards in Uganda and the safety standards in Uganda, according to design, we had to allow for those lanes there.
Thank you. What are the thermal requirements specifically as far as temperature rise and temperature fall?
I'm not really sure what that question means. Maybe if you can elaborate, but maybe what I understand from that is what the change in temperature over there could be roughly about 20 degrees, if I understand correctly what the question is.
Yep. Okay. I will let you follow up directly by email. Another question, where will the structural steel come from? Will it be imported?
That part there, we're not really sure. That is much dependent on the contractors, because on our side, we only specified, we ended on the design side and the drawings that were given to the client. In terms of the pricing, we did of course consider that there are options of actually importing the steel from places like South Africa, and other people actually prefer importing the steel from places such as China. But at the end of the day, it looks like it's a financial balance. It's a balance between money to say, okay, if we import the steel from South Africa, what are the travel charges going to be? And already, what is the current price of steel? Also taking into consideration the COVID-19 challenges. The same can be said for importing the steel coming from China. Similar questions can be asked. Is it coming by ship? Is it coming by or is it coming by road? So it's elements like that that should be taken into consideration, and we did look into it. But the chances are, we believe that it's going to be imported and not coming straight from Arua.
Okay, thank you. We will take the last question. There were additional more, which will be followed up directly by Kulani by email. Last question, since steel girders were finalized, was a single span bridge option considered instead of 2-span?
Had we considered a single span bridge, like we said, that would mean that the steel girder would now need to span a distance of 48 meters. Now, in order to span a distance of 48 meters, it means we'd need now deeper steel girders, and thus that would be increasing the cost of the bridge itself. And not only that, but also transportation challenges and also availability of such large steel members.
Perfect. Thank you so much. We're at the end of our webinar session. Please feel free to follow up directly with Kulani and Johnny via the contact details shown on the screen. And I would like to thank all attendees for joining today. And again, big thank you for a great presentation, Kulani and Johnny. Thank you very much. I will wrap up the webinar now.